Hi, welcome back to Allen 14 Presents. My name is Mark. Today I'm going to show you how you can build your own metal detector. And for that purpose I designed a pulse metal detector. This one uses an ESP32 and a graphic display, and it has a nice sound for you to detect metal. Of course I will show you how I built the electronics, and I will show you how to make your own coil, hook it all together, program it, and then you can start your own treasure hunt. So let's start building. Okay, so we start with the user interface. It has 4 potentiometers and a touch button, and I can use that to set some parameters. Of course, we have a power switch to disconnect the batteries from the circuit. We have our ESP32. We have a display unit that I use to generate some nice graphics, and I have an audio board with a speaker or a headset that you can connect, and basically the audio board is nothing more than a smart digital to analog converter, and theoretically I could generate or play MP3 files. So if you were able to detect gold, you can play some happy tune, that's totally up to you. Then we have our analog circuit, and basically the upper half and the lower half are identical, except the upper half has a little circuit to generate a pulse. Because that's what we do. We'll generate a pulse, send it to the coil, and then listen back on the same coil and follow the signal. And that signal that we listen back is offered to the analog digital converter of the ESP32, digitalized and then processed, and that way we can detect if metal is near. Now the second circuit on the lower half is basically the same, except it cannot generate a pulse, it can only listen. And at the time that I designed this, I had no idea yet if I'm going to use both the circuits or just one, or am I going to use the combined coil or not. So I built both, and basically I left both in there, and they're kind of useful. So it depends on what metal you're looking for and what coils you're using. Okay, so that's the schematic in a nutshell. Let's move on. Okay, to assemble the PCB, just follow the assembly drawing and take a look where goes what. And I suggest you start with the discrete components like resistors. That's what I'm doing right here. And when all the resistors are done, I will move on to capacitors and connectors, headers, and really delicate components like integrated circuits and the ESP32, the audio board, etc. I will do that last. And then flip over the board and start soldering. Bending the wires is one way to prevent all the components falling out when you flip over the board. If you have a better suggestions, please do let me know. And now I'm just going to let you watch me soldering and struggling to fix all those components in place. Make sure when you're done soldering to inspect the board closely and to see if you didn't make any short circuits when soldering or cutting the wires. Now let's move on to capacitors, and of course some nice discrete components that we didn't add yet. Of course I'm going to add the potentiometers, the switch, and of course the audio jacks, and 2 of those audio jacks are used for the coil actually. And the remaining components, and we're almost there. There we have the headers and the battery clips, and then to solder all this we need to flip it over, of course, and solder everything in place. Here we go. So when it's all done, flip it over to add the remaining boards. First we're going to add the ESP32. It's a Do-It Dev Kit 1. We're going to add the LCD. And of course the audio board. And with everything in place, it's time to move on to the next step. So to wind a nice coil, I basically used a cap of a sewer pipe. It's 125 millimeters in width, and I carefully use it to wind the copper wire around it, and then I will remove it later. It's approximately 120 windings. Over the diameter of the coil is 125 millimeters, as I said. So 120 windings, carefully wind it, and you have to find a way to do it. It's kind of tricky, but with a little practice you can get the hang of it. So that's the smaller coil, and we're going to do something similar for the bigger coil. But the bigger coil, basically I made a mold, and I will include a file for you so you can print it yourself. And this one has a brim, so the copper won't go off, at least not to one side, but be careful when you wind it that it doesn't come off while winding, because then you have to start over. What I'm doing now is wind it, and there are several ways, but this worked for me. So winding it while holding the mold vertically, and then I'll just start winding it carefully. Take your time, 120 windings. And I know it's annoying, especially if you miss one, because you'll have to start over. But give it a try, and after a while you'll get the hang of it. It only took me 3 tries, so I kind of wasted a lot of copper wire, but in the end I got it to work. So when you're done winding, you have to slip it off completely without damaging the copper wire or breaking the mold. Take your time, one step at a time, slowly remove it, and when it's all off, you bind it together with some Scotch tape, like I did in several places, to hold all together. And then you have a nice coil that we can put in our final housing. As you can see, you see some longer stretches of wire. That's where I actually missed the mold, but I can still make it work, but be careful. Okay, so this is where we put the coil in our housing, but before we do that we need to make a few adjustments to the coil. As of now, the coils are not shielded, but to eliminate any static on the ground that will give a false positive, we can put a shielding around the coil. For that we're going to use wire, simple wire, and we'll start at the beginning of the coil, where I simply start with using some tape. So that's the beginning of our coil, and then we simply going to spiral wind the coil like so, and just wrap that all around it, and this is what it looks like. It is important, the wire you see here is only one, because it's open end. Do not close that loop, because if you close that loop, the shielding will be a real shielding, and it will affect the coil, and it cannot detect anymore. So it's only to remove a static field from the graphs, and that's why we only do the shielding one way, and not a closed loop. We're going to do the same for the other coil. Yeah, and that's our second coil. Now we're going to put both coils in here. So we have this coil, we'll go in here. Oh man. And we have this coil that will go in here. Now what I need to do is fill up the holes with some tapes. I will do this. It's just for a prototype, and later when I fix the winding of the coil, that is, I can always put a little acrylic or so in it, 2-component, you know, to fill it up and make it permanent. But since this is a prototype and I still have to increase performance later, you know, I might have to open it up again, so that's why this time we're filling it up with tape only. Okay, so we'll mount some jack sockets to the coils so I can easily connect it to the main unit with some standard audio wires. And for that we're going to solder this one in here. Plug in the cables for the coils like this, and then the other end will go to the module right here. And as you can see, I also printed a lid binder, so that's good. In case you're wondering about the metal post I use for my metal detector, basically I did some recycle engineering. You know, I used an old crutch that I had from an injury I had on my knee a few years back, and they were just sitting there, so I removed the cap and I reuse it, and now one of those will become my metal detector. So nice, recycle engineering. A bit different than usual, because instead of writing each and every function myself, I decided to mess about with ChatGPT. So I used ChatGPT as a tool to write this code, and basically what I did, I fed ChatGPT my hardware schematic and I commented what I want, and then function for function I made it write some code, checking it, verifying if it works, and doing many iterations to get where I am now. So let me walk you through the code. Of course, we have a header in which I explain a lot, or which ChatGPT explained a lot of things. This one I added. It's important. I always make it a good habit to tell you what version of the libraries I use. And as you can tell, it's only one library, the TFT for the display, and all the other libraries are included in the ESP32 framework. I will get to that in a minute. We have our includes, and of course we define display, then we define our pins, our audio board, the layout of the screen, and then we are going to use the EEPROM for a calibration function, because when I start up the metal detector I want to do a field calibration of the coil before we start, and those values are stored in the EEPROM. Then we have buffers, not that spectacular. We have several display mode that we can use. We have an overlay mode, in hold to view, combined display, and a demo mode. The button handling, we have some variables for several functions. First thing, when you start up the system, it's going to run through setup, in which we initialize the serial port, the EEPROM, we define the pins, we see if we want to start demo mode or not. So if you press the button while switching on, it will go into demo mode. Let's not do that for now. So we set up the ADC, and then we initialize the display. We create some graphic sprites that we're going to use, and of course we initialize the audio, the EEPROM, and then some more stuff for the display. And then we're going into the main loop, and the main loop we always see the button. So each time we go through this loop, it will check if the button is pressed and handle it accordingly. Are we in demo mode? Then it will handle the demo, which is not. So let's skip on to the normal mode, which is here. First we're going to read our user interface, the potentiometers. We're going to clear the display, determine the we're not going to clear the display, we're going to determine the values of the potentiometers and display those values on the display. You can set several options. You can, let's see, you can set the blanking time, which means after a pulse is sent, it will wait a certain amount of time before it starts listening. The number of samples we're going to sample, the delay time between each sweep, and when you press and hold the button and you turn the most right potentiometer, we can also change the sample interval. You can just mess around with those parameters and see how that works out for you. So just take a piece of metal, hold it in front of the coil, and adjust your parameters accordingly so you have the best result. And that's it. And then we go back through the main loop. Of course, we have several functions, and well, it's too much to go through each and every one of those, so just take a look at the comments that are in here. You can always drop me a line in the project page at the Element 14 community if you have any questions about this software, and I'll do my best to answer each and every one of you. Okay, so when you detect metal, you wave it around like this on the floor in front of you or on the ground. It has to be in movement for it to detect metal properly. So what I'm doing now is, instead of moving the detector because of the limited space here, I will move the object in the ground. And as you can tell, yeah, it nicely detects. Change some parameters. That's it. So this is all I have for you today. I hope you enjoyed it. Remember to check out the project page at the Element 14 community. There's more info on how to build your own metal detector, and of course you can ask me questions or leave comments, and maybe you can give me a suggestion what are good places to go treasure hunting, because I'm planning to be rich anytime soon. Well, hope this helps. Until then, I'll see you in the next video.